Hello and welcome to 11.6, so the last section of Unit 11. This section is all about systems of equations. So hopefully you remember a little bit about systems of equations from last year, Math 1. So we're going to be given a linear and a quadratic equation, then we're going to have to solve or find where they are both equal. So if you have the graph, if you have a quadratic graph, it's a U shape like that, and then a linear is obviously a straight line. So wherever those two intersect, those are going to be your solutions. So as you can see, this has two solutions. So we're always looking for where x, or what x is equal to. So they intersect at this point at -1, 1, but we just want the x value. So x is equal to -1, and then right here 1, 1, so x is equal to +1. And also, this graph right here intersects at this point. So it only intersects at one point, so that means we have only one solution. So x, the x value here is 0, so x would equal 0. And then this one does not intersect at all, so that's how you get no solutions. So moving on to example 1, I'm going to draw the little x and y axis first before we graph these. So we're going to graph these two, and then wherever they intersect, those are going to be our two solutions. So if I wanted to graph this quadratic equation right here, so remember when we're graphing quadratic, we always start at the same point. So hopefully you remember what that point is called, the vertex. So there are no parentheses in this quadratic equation, so that means it's in standard form. So to graph something in standard form, we have to find the line of symmetry and then the vertex by doing x equals -b divided by 2a. There is no b value because there's no x. There's an x squared, but no x. So that means b has to be 0. A is 2, but that doesn't really matter because 0 divided by 4, anything, is 0. So in the vertex, we know that x is 0. To figure out the y value, I plug in 0 into x. So 0 squared is 0. 2 times 0 is 0. 0 plus 1 is 1. So our vertex is at 0, 1. Now to do the rest of the graph, you can make a table if you want, but the easier way, for me anyway, the easier way to do it is to use that pattern. So 1, 3, 5, 7, 9, and so on. It's just the odd numbers. But we always have to multiply that pattern by a. So in this case, a is 2. So I have to multiply all these numbers by 2. So 1 times 2 is 2. 3 times 2 is 6. 5 times 2 is 10, and so on. So our new pattern is 2, 6, 14, 18, and so on. But we're only going to use a couple of these. So what this tells us is that our first average rate of change is 2. So average rate of change is like a slope. So that means I go up 2, right 1. Then I do the same thing to the left side because it has to be symmetrical. So up 2, left 1. Next rate of change is going to be 6. So that means I go up 6, 1, 2, 3, 4, 5, 6, and right 1. And the same on the left, so up 6 and left 1 from the left point. So here's my little U shape. It continues to go up from there. So next is the linear graph. So it's probably been a while since you've graphed a linear equation, but you always start at the y-intercept. So the y-intercept is 5, so 1, 2, 3, 4, 5, so 0, 5. And then we use the slope. So the slope, or the constant rate of change, is -2, which means I'll go down 2, right 1, down 2, right 1. Or you can go up 2, left 1, up 2, left 1, up 2, left 1. So connect those. And we have an intersection, So we have two intersections, which means we should have two solutions. So we want to know what x equals on those two intersections. So this point is at -2, 1, 2, 3, 4, 5, 6, 7, 8, 9. -2, 9. This point is at 1, 3. So the x values are -2 and 1. So if this was a multiple choice question on a test, they would obviously give you these, or the correct answers as one of the choice, but they would put the y values in there too. So make sure you know what you're looking for. So you're looking for the x values. So in example 2, I'm going to make my little x and y axis first. So I'm going to graph, this time the first one's a linear function, so start at the y-intercept, so 1, 2, 3, 4. And then the slope is 3, so that means I can go up 3, right 1, or down 3, left 1. Oops, I messed up my little y-axis there. So down 3, left 1, down 3, left 1. So here's our line. Well, it should be a straight line, close enough. And then next we're going to graph the quadratic equation. So there are no parentheses, so this is standard form. So to find the vertex, we got to do the line of symmetry first. So x equals -b divided by 2a. So remember, this is the line of symmetry equation. But again, there's no b because there's no x. So b is 0. A is -1. So 0 divided by -2 is 0. So our vertex will be 0, comma something. So if I plug in 0 for x, 0 squared is 0, -0 is still 0, plus 4 is 4. So 0, 4 is our vertex. So notice that A is -1, which means our graph is going to be going down this time. So our pattern is still 1, 3, 5, 7, ... But I need to multiply by -1. So 1 times -1 is -1. 3 times -1 is -3, and then -5, and -7, and so on. So these are our average rates of change. So -1 means I go down 1, right 1, and then same to the left, down 1, left 1. Next is -3, so from the new point I go down 3, right 1. And then same on the left, down 3, left 1. And then 5, I go down 5, right 1, down 5, left 1. So here's our little U-shaped graph. So notice that we do have two points of intersection. So this point is at 0, 4, and this point is at -3, 1, 2, 3, 4, 5, -3, -5. So the x values for the intersections would be 0, so x equals 0, and x equals -3. So that's how you solve system equations by graphing. On the next page, we're going to have to solve without graphing, so we're going to have to solve algebraically. So when you solve algebraically, you're going to be given the two equations, so quadratic and a linear, and you're going to have to set them equal to each other. So x squared minus 7x, or minus 6x, excuse me, plus 10 is going to be equal to 4 minus x. So now we just solve for x in whichever way we can. So first thing we got to do is get one side equal to 0. I'm going to subtract 4. So x squared minus 6x plus 6 equals -x. Then I'm going to add x to both sides. So x squared minus 5x now plus 6 equals 0. So we have talked about 3 different methods to solve these things: factoring, completing the square, and quadratic formula. So quadratic formula takes the longest, so I'm going to try to avoid that if I can. B is an odd number, so I don't want to complete the square. So I'm going to try to factor it if I can. So I'm going to use my little box, my factor box here. So A is 1, C is 6, B is -5. So let's see if I can find some factors here that work. So 1 times 1 is 1. Then I need two numbers that multiply to equal 6, but also add up to -5. So if they have to add up to a negative and multiply to equal positive, they both have to be negative numbers. The factors of 6 are either 3 and 2 or 6 and 1. So I'm going to try -3 and -2. So 1 times -3 is -3, 1 times -2 is -2. When I add these together, I do get -5. So that means the correct numbers are here in the box. So if I factored this, I would get x minus 2 times x minus 3. And that still equals 0. So all I did was just factor this. So from the zero product property, I need either one of these to equal 0. So x minus 2 equals 0, or x minus 3 equals 0, and those will give me my two answers. So that means x equals 2, and x equals 3. So that's how you solve algebraically. So example 3, again, we're going to put the two equations equal to each other. So -x squared minus 8x minus 15 equals x plus 3. So I personally don't like to deal with negative numbers. So instead of subtracting the x plus 3, I'm going to add everything on the left. So add x squared to both sides. So I'll still be left with -x minus 15 equals x squared plus x plus 3. Then I'll add 8x. I'm going to add 15 at the same time. So plus 8x plus 15. So this becomes 0 on the left. On the right side, we have x squared plus 9x plus 18. So now that we have one side equal to 0, I can factor. So I can either try to factor or I can quadratic formula. I'm going to try to avoid. The other method is completing the square, but this is odd, so I can't really complete the square, or I don't want to. So let's try to factor. Let's use a different color, actually. I don't like that. All right, so A is 1, B is 9, and C is 18. So two numbers that multiply to equal 1 are 1 and 1. Then I need two numbers to multiply to equal 18 and also add up to 9. So if you're not sure right away, do a little factor tree of 18. So 1 times 18, 2 times 9, 3 times 6. Those are all the factors of 18. So out of these three combos, which two add up to 9? So that'd be 3 and 6. This would have to be 3 and 6. So 1 times 3 is 3, 1 times 6 is 6, and then 3 plus 6 is 9. So that means my answers are in here. So x plus 6 times x plus 3 equals 0. Oops. So I just need one of these to equal 0. So x plus 6 could equal 0, or x plus 3 could equal 0. So that means my answers are going to be -6 and -3. And finally, the last example. I think I'm just going to hold off on doing this. It's the same thing. If you want to try it on your own, I recommend that. And then you can go to my website to see if you got it correct.